Good morning, one and all. I, Professor Ram Kandare from First Year Engineering Department, behalf of Dr. D.Y. Patil College of Engineering and Innovations, Varale Taregaon campus. So, students, I will take the start you the basic electrical engineering subjects. Let's start with the unit number first, electromagnetisms. Everything is a concept actually present in that the name of the topic, electromagnetisms. These are the content in that magnetic effect on electric current. When the current passing through the any conductor, the magnetic field, how the magnetic field generated around it, that's a concept is called the magnetic effect on electric current. Second thing is the right hand thumb rule. Same we all already learn in 8, 9 and 10th, 11, 12 class that right hand thumb rule. Nature of magnetic field along the solenoid, nature of magnetic field in the straight conductor, nature of magnetic field along the toroid, simple series magnetic circuits, comparison between the electric and magnetic circuit. Before we start the first unit, I would like to discuss with the simple concept what actually the current, the flowing of a charges, it's we call as a current. Force to require to flow of a charges, it's called as a voltage. We are all know the what is the unit of the current is the ampere, voltage is the voltage is we are unit like V. Second thing, main concept is there is a direction of a current actually in that the electromagnetism there is a one concept of that the cross and dot convention. There is a one current move towards that the observer, it's we call as a cross convention, and current flowing away from that the observation we call as a dot conventions. And some concept we will discuss. What is the mmf, what is the magnetic motive force, what is the flux density and reluctance. What is the flux is nothing but the imaginary lines of a force, it's called as a flux, and the unit is a Weber, and 1 Weber is equal to 10 raised to 8 imaginary lines. Magnetic motive force is nothing but the force required to flow up the flux, and the unit is the mmf. It's the unit is the at, and its definition actually the formula is nothing but the mmf is equal to n into t, and n is nothing but the number of turns denoted by unit t, and ampere we know that the unit is current's unit is the ampere. As the unit both of that is at. mmf unit is a and t. Flux density we know that we are already discussed, we are all learn in that 8, 9, 10 density is the region per unit area. It's like I will give the one example. It's supposed to be student present in that the class, and we would like to find the density of that class is nothing but the student per unit area. It means that the quantity per unit area. The same flux density is nothing but the flux per unit area. Flux is nothing but the Weber, and area unit is the m square. The what will be the unit is flux per meter square. What is the reluctance? The opposition of a flow of a flux, it's called as a reluctance. So we will move towards that the magnetic effect on electric current. What will the magnet? Just we have discussed that the magnetic flux unit is the Weber, magnetic flux density unit is the Weber per meter square. What is the unit of mmf? At. What is the unit of the reluctance? At per Weber. And permeance is nothing but the reciprocal of the reluctance. Is means that it means that At per Weber raised to -1. It's nothing but the unit of that permeance. The let's move towards that the first concepts, and the first concept of that unit is the magnetic effect on electric current as shown in that diagram. If supposed to be, it's like its diagram like it's only for the magnetic field. We will discuss with the magnetic effect on electric current. I will draw one diagram. if suppose one core and wire will be the wound around of that, and we will fed the supply positive and negative. What will be the happen when the current passing through that magnetic field is magnetic flux and magnetic field is generated around it. So that concept we call as the magnetic effect on electric, that concept we call as a magnetic effect on electric current. So we will move towards the next, right hand thumb rule. When the any conductor we have hold and the right hand, the thumb indicate that the direction of a current and the remaining four finger indicate or denote the magnetic direction of magnetic field, indicate the direction of a magnetic field. It's nothing but the direction of magnetic field, and that shows the direction of thumb indicate the direction of a current. Next concept is the nature of magnetic field along the solenoid. Just what actually the concept of the solenoid, we have take the one core and wire we have to wound around of that, and we have to fed the supply to that core, supply to that conductor. What will be the happen, the magnetic fluxes it will be the generated around it. So nature of magnetic field along the solenoid, to we have to find the magnetic field strength. What is the magnetic field strength? What will be the formula of that? MMF divided by actually L. So MMF divided by L. So when the current passing through that, the magnetic flux is generated around that, and as shown in diagram, it's nothing but the one core. The length of is nothing but the L is nothing but we can denote that the length of that core, and it's nothing but the turns, we can denote it the N, and current passing through that we are denoted the I. So what is the magnetic field strength? How we can find? H is equal to MMF divided by L. So N I divided by, we having the N, we having the I because current is passing throughout of that, and we having the length. What actually the length of that? It's a linear length, so we can write the L. What will be the field strength of that solenoid? H is equal to Ni divided by L. Many times that question is asked in that exam, the nature of magnetic field along the solenoid. What actually the solenoid concept? When the core we have to wire wound around of that and fail the supply to, after the fail the supply, magnetic fluxes is generated around it, and we have to find the magnetic field strength, that MMF divided by L. So next topic, next concept is the nature of magnetic field in the straight conductor. Before start with that, we will consider that any one conductor we will kept in one axis of any three-dimensional. If suppose x, it's y, and it's z, and it is nothing but the region where the magnetic field can be the generated around it, and it is nothing but the length. So it's a circular, it's like a circular magnetic field generated around it when the current passing through that conductor, as shown in that animated diagram. So what actually the we have, what how we can find the strength? H is equal to MMF divided by L. So the magnetic field generated around it, it's like a circumference of a circle. So we can uh, take the formula like a 2 pi r, circumference of a circle, H is equal to, and already MMF is nothing but the Ni, or circumference of a circle is nothing but the 2 pi r. But keeping in mind that as in case of the straight conductor, we are just using the conductor, but there is absence of any types of a turns, so we are neglect it, or we are not considering the turns. So we will get the formula H is equal to I divided by 2 pi r, because turns are absent in that the conductor. So next point is like nature of magnetic field along the toroid. It's like one core we have to take the like a circular, and wire is wound around it. It's called as a toroid. And when the supply is fed to that, magnetic flux is generated like a circular. So just we have discussed that what will the magnetic field strength. So H is equal, H is equal to mmf divided by mmf divided by L. But we can see here there is a having the turns, current also passing throughout of that I. And how it's look like the circumference of a circle. So we will get the H is equal to Ni divided by 2 pi and r. Ni divided by 2 pi r. Same in case of magnetic. Just before we have seen that the uh, solenoid, there is a length, what will be the field strength? H is equal to Ni divided by L. In case of straight conductor, H is equal to Ni divided by 2 pi r. Ni not, there is a I in N, we are not considering. I divided by 2 pi r in case of that conductor, and in case of toroid, H is equal to Ni divided by 2 pi r. So just we have already discussed that the flux is the imaginary lines of a force. What is the series and what is the simple series magnet circuit? Simple series magnet circuit, we know that when the any resistors are in the series, means that the same current is passing through that and voltage is different. As per electrostatics Ohm's law, we consider we know that I is equal to V divided by R, and magnetics Ohm's law, phi is equal to mmf divided by S. So I stands to phi, V stands to mmf, R stands to S. So when in case of the series, always current is same. Got it? So we consider that the magnet A, magnet B, and magnet C are connected such a way that connect to the each other. When supply fed to that winding or that coil, the same fluxes is generated, and same fluxes is passing through the entire coil. Same flux is passing through the entire coil, means that a coil B, and coil C. So how it is? So it's supposed to be, we have to find the formula for that, the reluctance. So what actually the same? Current is same. Current is same is that flux is same. What is the different? mmf different. So we can write that mmf t is equal to mmf1 plus mf t is equal to mmf1 plus mmf2 plus mmf3. Why mmf3? Because we are using the 3 coils. So mmf is nothing but the phi is equal, mmf is nothing but the phi into mmf is nothing but the phi is equal to mmf divided by S. So the mmf is equal to phi into S. The same fluxes is passing through that. So the mmf t is equal to phi into S1 plus phi into S2 plus phi into S3. So we will get phi into St is equal to, we will take the common all phi. So phi is equal to S1 plus S2 plus S3. So phi gone cancel. So we will get the St is equal to S1 plus S2 plus S3 in case of the simple series circuit. Or in case of parallel, In case of that parallel, what will be the same? Voltage is same. Voltage is same means that phi is equal to I is equal to V divided by R, and phi is equal to mmf divided by S. The V stands to M means EMF is equal to what is the different? Current is different. So current is different is equal to phi is equal to phi t is equal to phi 1 plus phi 2 plus phi 3. So phi is equal to mmf divided by st is equal to mmf divided by s1 plus mmf divided by s2 plus mmf divided by s3. All mmf are same, so mmf going to cancel. We will get, in case of parallel, st is equal to 1 upon s1 plus 1 upon s2 plus 1 upon s3. So noted that in case of that series, st is equal to s1 plus s2 plus s3. In case of parallel magnetic circuit, 1 of reciprocal of 1 by st is equal to 1 upon s1 plus 1 upon s2 plus 1 upon s3. It's very simple. Fleming left hand and Fleming right hand. When we have to uh, write the same two sentence, we have to remind that same two sentence we have to write in case of Fleming left hand and Fleming right hand. When three fingers stretched such a way that they perpendicular to each other, they are perpendicular to the each other. The in case of Fleming left hand, the Fleming left hand, the thumb indicate or denote the force, index finger shows the field or flux, and middle finger shows the current. And in case of the Fleming right hand, the thumb shows the motion, index finger shows the field, and the middle finger shows the current. It's very simple rules. Now comparison between the electric circuit and magnetic circuit. Here is the electromotive force, there is the magnetic motive force. Here is we are considering charge, there is we are always considering the fluxes. Here is we are considering the magnetic field, there is we are considering the electric field, there is a resistance, there is a reluctance, so etc. Number of points we can be easily write. If supposed to be you have seen my that entire video, then you can easily can compare that the both electric circuits and magnetic circuits concepts. That comparison is very easy. Thank you all. It's a first unit. It's not actually the entire syllabus. If supposed to be you want, I will prepare next video, and that same video I will be the uploaded in my YouTube channel. Please subscribe and see my channel. Thank you, and thank you so much. Thank you.